Hey Sea King, so continuing on with example 3, I have skipped example 2. It was a story problem, but it was really a paragraph with an equation in the middle, so that's not challenging enough for you because you guys are such great mathletes. Okay, so example 3, they want us to graph and solve. They've given us the square root of 2x plus 7 equals x minus 4. So my first step, again, I'm going to break it into two pieces. So we'll say y1 is the square root of 2x plus 7, and we'll say y2 is the line that has a slope of 1 and a y-intercept of negative 4. So finding, really this is what step 1. So if I find the x-intercept for y1, that means that y equals 0. So 0 equals the square root of 2x plus 7. I square both sides, I get 0, square both sides, equals 2x plus 7. When I subtract 7, I get negative 7 equals 2x. And then I'll divide by 2 here, and I get negative 3.5 equals x. You can leave it as a fraction if that's better for you. So that gives us the point negative 3.5, comma 0. My next step will be to find the y-intercept. And to do that, I'll let x equal 0. So I have y1 equals the square root of 2 times 0 plus 7, which is really just the square root of 7. And that gives me 2.6 on my calculator, or approximately 2.6. But again, for our little graphs, it'll be just fine. Now I need one more point. So we said negative 3.5 gave us 0. We said 0 gave us 2.6. Let's go with positive 3.5. Why not? That seems adventurous. So that means that y1 equals the square root of 2. And I'm going to use 7 over 2 in this case, just so that the 2's will cancel very politely. So that gives us the square root of 7 plus 7. For the square root of 14, which my calculator tells me is about 3.7. 3.7, yes, okay. Alright, so let's get our graph on here. Close your eyes for a second. Okay. And graph. So what should we do with 3, 3.7, 4? I think we can go by 1s on both graphs. So I'll write 2's here so it's a little bit more obvious and the 1 doesn't blend in with this vertical line. So anyways, we have 0, negative 3.5. I'm sorry, negative 1, negative 3.50. 1, 2, 3.50 starts out right here. We have 0 is at 2.6, so a little bit more than halfway between the 2 and the 3. And 3.5, 3.7. 1, 2, 3.7 is about here. So here's our square root curve. Looks good. Okay, so we're calling this y1. And then y2 is x minus 4, so that's a line. 1, 2, 3, 4 is the y-intercept. Up 1 over 1 for the slope. Here's our line. Oh, it's not going to show up on our graph. Where do they cross? Oopsie daisy. Something like that. There we go. Here's my y2 equation. So we'll have to solve them. Okay, so here we go. So we have the square root of 2x plus 7 equals x minus 4. Now I have a square root, but I have x's on both sides, so I need to be a little bit careful here. So I'm going to square the left side, and I'm also going to square the right side. So the left side becomes just 2x plus 7. However, the right side, this is a binomial, and when I square it, I can either FOIL it or use a Punnett square in the area model, or I can use my shortcut. So I'm probably going to use that. So x minus 4 squared should be x squared minus 8x plus 16. Okay, so since the x squared has a positive coefficient on the right side, I'm going to move everything over here in hopes that I can either factor it or use the quadratic formula. So 0 equals x squared. This 2x, I'm going to subtract it from both sides, so that will combine with this negative 8x to give me negative 10x. The 7 I'm going to subtract from this positive 16, so I think that leaves me with positive 9. Let's see, does that 9 and 7 is 16, so that's right. Okay, so here it looks like if I have x minus 1 times x minus 9, that will add up to give me the negative 10x, and will multiply to give me the positive 9. So that means x equals 1, or x equals 9. Now, x equals 1, these are not together, so that answer won't really work. X equals 9, I believe that's a possibility because it would be over here somewhere. So let's try them both. So what happens when we let x equal 1? We have the square root of 2 times 1 plus 7. Does that equal 1 minus 4? Oh. Can you see the dilemma already? So this is going to be the square root of 8. Sorry, just kidding. 9. And this is going to be 1 minus 4. So this will be 3, and this will be negative 3. So when I see this set up initially, I knew this was going to be negative, but because this is a square root, I know the answer to a square root is going to be positive, unless I create the square root and I have to say the plus or minus. So that answer is no good. Now when x equals 9, what do we get? Oh, close your eyes. We have the square root of 2 times 9 plus 7. Does that equal 9 minus 4? So this is going to be 18 plus 7, the square root of 25, which is 5, equals 5. Yes, that's much better. So this definitely works. So, when you square something, when you have a square root and you do the squaring, you have to be very cautious and check the answers, because this squaring process here can introduce what are called extraneous solutions. Let's see, we need to write that. So, squaring both sides of an equation. I should be putting this in the margin, but either way, squaring both sides of an equation can introduce extraneous solutions that do not work. Introduce extraneous solutions. Maybe we'll put the definition of extraneous solutions in the margin. So, double check them. Now, this is why I wanted to graph these. You're thinking, we end up solving them anyways, why are we even graphing them? So that you can kind of see what's happening. So we square this, but then that makes this go from a line kind of to a parabola. That's what sort of creates that other false option. So, what is an extraneous solution? So an extraneous solution is just a solution that's not really a solution of the original equation. Well, this is terrible. An extraneous solution, don't write that as as a hyphenated word. An extraneous solution is a solution that does not satisfy the original equation. So an extraneous solution is a solution that does not satisfy the original equation. So how do you know you have an extraneous solution? Either you can draw the graph and see it doesn't make sense what they're suggesting, or you can check it in the original equation, which is what we did to see that we got 3 equals negative 3. Please be very cautious of that. I can guarantee there will be a problem that has extraneous solutions on the test. So Anytime you're squaring or raising to an even exponent, you're going to want to check that.